That minus x, y equals minus x squared plus 5x minus 9, find dy by dx from first principles. Right, well, I personally like to use f of x notation, so I'm just going to state that f of x equals our equation that y is equal to, so minus x squared plus 5x minus 9. Now I'm going to find f of x plus h, which will give me minus x plus h squared. So all I'm doing is substituting the x values for x plus h, plus 5 lots of x plus h minus 9. When I work through this, I get x squared times by the minus, gives me minus x squared. I get 2xh times by the minus, which gives me minus 2xh. I get h squared times by the minus, which is minus h squared. Plus 5 times x, which is 5x, plus 5 times h, which is 5h, all subtract 9. At this point, I like to calculate the difference between f of x plus h minus the f of x. So I get minus x squared minus 2xh minus h squared plus 5x plus 5h minus 9 minus x squared minus 5 plus 5x minus 9. Okay, if you check through, minus x squared is positive x squared. That's going to cancel with my negative x squared, so we can cancel these two terms out. Minus plus 5x, well, here we have a plus 5x, so these two terms are also going to cancel out. And then minus the minus 9, so that gives me plus 9, will cancel out with the minus 9, and so that cancels out. And an easy way to do this step is just focus on the three terms that you are, or focus on the terms you are subtracting. There will be one term that pairs up with it, and then every term that is left should contain a h. So for example, we get 2xh minus h squared plus 5h. Next stage, I want to divide this result by h, so f of x plus h minus f of x, and you should make sure your working includes all this notation so at each stage you can see what step you are doing. So I'm going to divide this expression all through by h. This is why it must all contain h's in, because otherwise we can't divide through. So dividing minus 2xh, I just get 2x. Dividing minus h squared, I get minus h. And dividing the plus 5h, I get plus 5. The final step to get dy by dx, so dy by dx is equal to the limit as h tends to 0 of f of x plus h minus f of x all over h equal to, and then so any term containing h here will have will go to 0, and so I get left with minus 2x plus 5. How are you awarded marks in this question? Well, initially you get a standalone statement mark if you substitute x plus h, also some equivalent notation, into the original quadratic. Secondly, you get a method mark if you attempt to find the difference between your first line here, the f of x plus h, and the f of x. You get an accuracy or answer mark if you get to an equivalent expression at this stage here, 2xh minus h squared plus 5h. Your next mark is given for, or method mark is given for, if you divide by the h and take the limit of h tends to 0. So only once you've taken that limit and demonstrating you're taking the limit of h tending to 0. And then finally, you get an answer or accuracy mark for the correct answer only of minus 2x plus 5 or 5 minus 2x. Let's look at part B. Part B says, given that y equals 3/4 x to the third plus 12x to the minus 2, find the values of dy by dx when x equals 8. Well, before I attempt to differentiate, what I need to do is rewrite this reciprocal so that it's in polynomial form so that I've got a negative index. So I'm going to have 3/4 x to the third plus 12x to the minus 2. notice the use of notation so that I can be clear on when I'm differentiating and when I'm just rewriting the expression. So differentiating, I get dy by dx. It's worth perhaps taking a stage to work this out. I'm going to multiply by the power, so I'm going to get a third times 3/4 x. Decrease my power by 1, so I'm going to subtract the denominator from the numerator. 1 minus 3 is minus 2, so that goes to the power minus 2/3. And then I get plus minus 2 times 12, so I get minus 24x, and the power decreases, so the power decreases to minus 3. Just be careful, don't decrease it to minus 1. Okay, let's tidy up this expression. So, because in a moment I want to actually calculate a value for dy by dx. So in my first term, the third and a 3 will cancel, so what I get is 1/4 x to the minus 2/3, and then we get minus 24x to the minus 3. Now, since I want to calculate with this, I now want to really understand my roots and reciprocals a bit better, so I'm going to rewrite this using roots and reciprocals. So I get dy by dx minus 2/3, so this is going to be a reciprocal. 2/3, well, that means x squared, and it's going to be the cube root of x squared. So it doesn't matter which way around we do this, cube root x squared minus 24, and it's a reciprocal, and this one's a little bit simpler. X to the minus 3 is reciprocal of x cubed. Now, when x equals 8, I want to evaluate this. So I get dy by dx equals 1 over 4. It's easier to take the cube root of 8. I know the cube root of 8 is 2, rather than squaring 8 and then trying to find the cube root. So it's easier to find the cube root of 8. Minus 24 over 8 cubed. So evaluating this, dy by dx equals, cube root of 8 is 2, squared is 4, times by the 4 gives me 16. So I actually get 1 over 16 minus 24 over 8 times 8 is 64, times 8 again is 512. Okay. Finally, let's just cancel this fraction. We'll get there in a moment. I'm going to get 1 over 16 minus, I can divide both top and bottom by 8, so I get 3 over 64. And now I just want equivalent fractions. So dy by dx times the first fraction, top and bottom, by 4 to get it over 64ths. So I get 4 over 64 minus 3 over 64, which gives us an answer of 1 over 64. How are the marks awarded in this question? Well, you get in the differentiation stage 1 mark if you have demonstrated this first term here correctly, 1 mark, and both of these are standalone marks if you've demonstrated how to get the second term here correctly. There's 2 more marks remaining. You get 1 B1 standalone mark if you get either of these 2 terms correct once you've substituted in the value x equals 8, and then you get the final B1 standalone mark if you work all the way to get that dy by dx is 1 over 64. Well, I hope that all made sense and that you understood what I was saying.